also going to talk about absolute values with regard to inequalities. Okay, and so we'll start off with an absolute value that's less than a number. And so what's interesting is that when you deal with absolute values and less thans and absolute values with greater thans, you're going to have two different situations and you have to keep them straight. So the first one is less than. We'll start with that one. So let's say I had an absolute value of x is less than 5. We'll just start with something real basic. Well, just think about that in terms of the definition of an absolute value. You're thinking about what numbers can you plug in whose absolute value is less than 5, okay? Or whose distance from 0 is less than 5. Let's picture it on a number line for a moment. Well, I'll put 0 towards the center. And I want all numbers that are closer to 0 than 5. Okay, so whose distance from 0 is less than 5. That's how this reads. So all the numbers that are closer to 0 than 5 is going to be everything between -5 and 5. It's all the numbers in between there, right? Like -2 or 4.5 or -3.78. Those are all numbers that are closer to 0 than 5 units away, all right? So everything in this interval from -5 to 5. Now I would not include the endpoints because 5, for instance, is a distance of 5 away and I want only things less than. -5 also is 5 units away and I want things less than. So I would not include those in this example. I would include the endpoints if I had a less than or equal to sign here. Okay, so the interval plotted in a graph form runs from -5 to 5. And so how I would rewrite this is I would rewrite it as a compound inequality where -5 is less than x, which is less than 5. Okay, we saw this when we dealt with compound inequalities in previous videos where the x is in between the -5 and the 5, and the interval given here is the intersection of two intervals where -5 is less than x and x is less than 5. Okay? The solution then could be written in two different ways, either as an interval from -5 to 5 or as a solution set x such that -5 is less than x is less than 5. So either of these two representations, the interval or the solution set, will be correct, although I believe my math lab is interested in the interval. Don't quote me on that. You may find that it asks for a solution set at times as well. When it comes to a test, I would probably let you use either one, or I will state in the instructions which one to represent it as. Okay. Let's try something a little bit more complicated. Let's throw some more stuff in the absolute value. Okay, so this stuff works when you have an absolute value less than a number. Okay, so let's try something like the absolute value of 3x minus 7 is less than let's go with 19, something like that. Okay, so in this example, again, I have some stuff in an absolute value less than, actually let's make it less than or equal to 19, okay? So I know that the stuff in the absolute value has to have a distance between, or distance from 0 that's less than 19. So it itself, the stuff in the absolute value, must be contained between -19 and 19, including the endpoints here because of the equal sign. So if I were to represent this on a number line, for instance, and you don't have to do the number line, I'm just giving you kind of a visual for those of you who are more visual thinkers like I am. I would put in here a -19 and a 19 because I know with certainty that whatever's in the absolute value has to be between those two values. Whenever, if I have an absolute value with a less than symbol, it's gotta be pinned in between. And so, in here is 0 somewhere. And so this stuff, all the numbers in between are represented by the 3x minus 7, whatever's in the absolute value. And so if I were to rewrite this in a form that I could then solve, it would be a 3-part inequality with the 3x minus 7 in the middle. So it would look like negative 19 is less than or equal to 3x minus 7 is less than or equal to 19. Then I could solve this 3-part inequality, just like we did in a previous video, just add the 7, but I have to do that to all 3 parts. So I get negative 12 is less than or equal to 3x, which is less than or equal to 26. And I divide out the 3 on all 3 parts. And I get negative 4 is less than or equal to x, which is less than or equal to 26 thirds. Does not reduce. It is a mixed number, but I'm going to leave it in fraction form there. All right, so my solution then is between negative 4 and 26 thirds. My final representation of the answer could come in 2 different ways. Again, the interval form, which would be negative 4 comma 26 thirds with brackets on either side, or in set form, x such that negative 4 is less than or equal to x, which is less than or equal to 26 thirds. Okay, so again, either the interval or the solution set would be sufficient here, okay, depending upon what the instructions ask you for. Okay, so again, the main thing to keep in mind when you have an absolute value less than a number, you break it down into a 3-part inequality every time. The stuff in the absolute value goes between the endpoints. The endpoints are the positive and negative version of the constant on the other side. Okay, so let me give you just a quick structure then, as a general rule. If you have some stuff, I'll make it like a cloud, some sort of weird shape. You got some stuff inside an absolute value, and that's less than a number. I'm going to call it C for a constant. Then that stuff must be in between negative C and positive C. Okay? Must be in between those two. And then from that point, you can solve. It's a 3-part inequality, so you solve it just like we would over here. Now there is a condition on this. The C value must be positive in order for this to work. If the C value were negative, or 0, in fact, we'd have a different situation. I'll talk about the negative situation here for a moment. Let's consider the case where you have an absolute value that is less than a negative number. Let's say negative 9. Absolute value x is less than negative 9. Well, here, I'm trying to figure out what numbers I could plug in to the absolute value to get out a number less than negative 9. Well, all of these absolute values, no matter what I plug in, we're going to have positives or 0 as the outputs. Are positive numbers ever less than negative 9? No. Is 0 ever less than negative 9? No. There are no numbers whose absolute value is less than negative 9 because the absolute values are always positive or 0, which are greater than negative 9. And so in this situation, there is no solution. There's no solution because absolute value of x is never negative. Okay, it's never negative. And the only numbers that can be less than negative 9 are other negative numbers. So that wouldn't work. Okay?